This is Unit 2 Polynomials, Lesson 2.5 Multiplying Polynomials. In this lesson, you are going to be introduced to 3 different methods of multiplying polynomials. You might find one of these methods easier for you to understand and use than the other, but do attempt to try all 3 so that you can compare them. They may seem difficult at first, but with some practice, you may find one a lot easier than the others. Of these 3 methods, there is one method that can only be used in one situation. So you may or may not want to use that, or you may have to learn 2 methods and get used to using 2 of them if you choose that method. The first method I'm going to be demonstrating with certain types of problems is called the binomial method. Binomial. And actually, even though I'm going to be demonstrating with binomial expressions, this method can be used with trinomials and any larger polynomials. So this one can be used with all different types of expressions when you're multiplying. Now, I usually nickname this method the old school method. The old school method of multiplication. School. And the reason why I call this the old school method is that this is very similar to when you are multiplying 2-digit numbers times a 2-digit number, or even a 2-digit times a 3-digit number. When you have any digit numbers, you usually write them one on top of the other. Let me use a different number here as an example. So here, let me try over again. Let's try a different example, sorry. So this is not on your notes. You might want to write it on the side just to give it an example of how you would set this up. Let's say you had the number 12 times the number 34. How would you multiply this in the old school method? Well, you would start with the 4, and when you multiply it by 2 first, 4 times 2 is 8. And then take the 4 and multiply it to the tens digit. 4 times 1 is 4. And then wouldn't you move over 1 and multiply the 3 times the 2 to get 6 and write it down below the 4? And 3 times 1 is 3. Some of you might put a 0 right there just as a placeholder. And then the next step to the 2-digit multiplication is you would have to add those 2 partial products together. So 8, 10, carry the 1, and that would be 408. So in this method of multiplication of binomials, it's sort of the same or familiar method that you're used to. We're going to take our 2-term expression, or our binomials, and write them one on top of another. So I'm going to write x plus 6 over x minus 5. And you're going to treat each term like it's a digit in the old school method. For example, let me change my pen color so you can clearly see what I'm doing. I'll start with the first term of negative 5. And I'll multiply it to my first term on top, the positive 6. Negative 5 times positive 6. Negative 5 times positive 6 is negative 30. Now, unlike the old school method, we're not going to carry. The next step, I would take that negative 5 again and multiply it to the next term, the x. So negative 5 times x is negative 5x. So I have one of my partial products. Now I need to do the other partial product. I'll go to the next term on my bottom number there, or the bottom expression. The x times the 6, and I need to write 6x. Just like the old school method, you need to move over 1, or basically write it right underneath the other x term from our previous partial product. Then I would multiply, and that's a positive 6x. Then I'd multiply that same x to the other x in the first expression. So x times x is x squared. And I just realized I went off the screen here, so I may need to rewrite this problem just a little bit so you can see. I'm just going to rewrite them right over here to the side. So I apologize, that's just so that you can see how I'm going to get the final answer. So negative 5x minus 30 is the first expression, and the second expression was x squared plus 6x. If you need to put a plus 0 just as a placeholder, you can do that. Now this is just like when we were adding polynomials in the previous lesson. Negative 3 plus 0 is negative 3. Negative 5x plus 6x is positive 1x. And then x squared plus nothing is just x squared. So this is our final answer. X to the second plus x minus 3. So this should feel very familiar to you. Let's try another example. I did recopy the original problem, so I had some room to do the second example for you. Alright, for example 2, we have a 2 term times the 2 terms. So I'm going to write the first term, 2x plus 4. And then the second expression is 3x minus 9. So using the old school method, I start with my first term, just like a first digit. Negative 9 times positive 4 is negative 36. Negative 9 times the 2x is 18x. I'm ready for my next partial product. So I'm going to multiply this 3x times the constant term, the 4. 3x times 4 is 12x. I make sure I write it underneath the other x term. Just move it over one. Then multiply the 3x times the 2x. 2 times 3 is 6. X times x is x squared. See how that's different from adding variables? When you add variables, you just add their coefficients. When you multiply variables, you need to remember that you add their exponents. So that x to the first and x to the first, if you add the two exponents together, it would be x squared. So that's where I got the x squared from. Now I need to add up my partial products. 6x squared plus 18 plus 12 is what? 20 is 30. 30x minus 36. Right? So that's the old school or binomial multiplication method. This next method is called the FOIL method. F-O-I-L. It gets its name because the letters F-O-I-L tell you the steps in which you should multiply. This method may only be used when you're multiplying a binomial times a binomial. So it does have limitations with the type of problems you can use it for. Now most textbooks will use the FOIL method to multiply binomials times binomials. So it's often used and often taught in schools. FOIL stands for first, outside. Some books call it outer instead of outside. Just know that those words mean the same thing. Inside. Oops. There we go. I forgot the end there. Inside or inner means the same thing. Last. So to remember that the FOIL method is used when you're multiplying binomial expressions or when you're multiplying two-term expressions that have parentheses, there's a little song that you can also use with the word FOIL. It goes like this. First, outside, inside, last. First, inside, outside, last. This is what you do when you multiply two sets of parentheses with two terms. Kind of annoying, also kind of catchy. You won't forget it. Now, to start multiplying your first, outside, inside, last, you usually draw arcs to show what you're multiplying. I'm going to do these in 4 different colors so that you can clearly see what I'm multiplying. The word first refers to the first term in each expression. So the first term in my example 3 is the x in the first expression and the x in the second expression. I'm going to show that I'm multiplying these two together with an arch. X times x equals x squared. Outer or outside refers to the first term of the first expression and the last term of the last expression. So this is what I mean. These two terms right here, the x and the negative 2, are on the outside of both expressions. I can show this multiplication again using an arch. I'm going to do my arch down below here like this. Do you see they're both on the outside? Multiply the x times negative 2 is negative 2x. Inside or inner refers to the two middle terms right here. So 5 or positive 5 times x equals positive 5x. Let's see, what color haven't I used yet? I'll go ahead and use blue again. Last refers to the last term in each expression. So this positive 5 and this negative 2. I'm going to draw an arch to show what I'm multiplying. 5 times negative 2 is negative 10. If you've done the multiplication correctly or drawing your arches correctly, it kind of looks like we've got unibrows and eyes, nose and a mouth. So a little face to just double check that you did do your multiplication correctly. Now we're not done with this problem. If you notice in our expression for an answer we have some like terms. And whenever we have like terms, we do need to combine them. There'll always be the outer and the inner that you'll have like terms to combine. So our final answer will be x squared. And you need to combine the negative 2x and the positive 5x. So that's positive 3x minus 10. Let's try another one. So remember our phrase, first, outside, inside, last. So the first thing we need to do is our first two terms. Those two right there. So y times 2y is 2y squared. Look to see where your outers are at. Think about it for a second before I draw it. Here's our two outers. Sorry, I used a different pen color than before. I'll go ahead and switch back to the same color I used before. So our two outers. Y and positive 5 equals positive 5y. Then you're ready for your inside. There's the inside, our nose. Negative 7 and positive 2y is negative 14y. And then we're ready for our last. The last two terms. There's the other eyebrow. Negative 7 plus 5 is negative 35. Are you getting your signs right when you're doing these in your head or writing them down? If you're forgetting the rules for multiplying integers, the sign rules, remember you can use your TP to help you remember the rules for the signs and cover up. Alright, we're not done. We have to combine our like terms. So our final answer is 2y squared. Combine our inner and outer, or outside, inside. 5y and negative 14y is negative 9y. minus 35. So that's the second method, called the FOIL method. It can only be used, though, when you're multiplying a two-term expression times a two-term expression. The final method I'm going to show you is called the box method. This is sort of new, especially for textbooks. You probably won't see this in textbooks, but we do find that most students like to use this method, the box method. It can be used for any number of terms in a polynomial, and the one thing that's nice about this method is it does keep things really organized. As you saw in the FOIL method, we had lines just going absolutely everywhere. So in this method, you have to draw a box that has the same number of columns as one expression and the same number as rows as the other expression. For example, in example 5, we have a two-term expression. So I have two columns. Above each column, I'm going to write the term just above the column. So I'm going to write the y, that's the first term, and the -8 is the second term, above each column. For the second expression, you have another two-term expression, or binomial. So there's the first term and the second term. And we're going to write them vertically or show the rows. So our first row is going to be called 2y, and our second row is going to be +3. Inside the boxes is where you're going to show your multiplication. And this is sort of like playing Battleship. So you're going to multiply the first row times the first column to fill in that first box right there. So 2y times y is equal to 2y squared. Then you're going to be multiplying that first row times the second column. So 2y times -8 is equal to -16y. Keep it inside the box. The box is to help you stay neat, so try to write neat and stay neat inside that box. The next multiplication you do is the second row times that first column, or that y. So 3 times y is 3y. And then the last step is multiply the second row times the second column. So +3 times -8 is equal to -24. Alright? So our multiplication is real clear to see, and it's really hard to make a mistake there with your multiplication. The next step is the combining of like terms. You will write your answer, or the like terms that it will always combine is this diagonal right here in the middle. So you will write 2y squared, combine your diagonal, and then -24. So here's our final answer, what it looks like. 2y squared. Combine the 3y and the -16y. So that's -13y minus 24. Pretty neat? Alright, so generally the boxes will not always be written for you. In fact, they will not be written for you if you decide to use this method. So you'll have to make your own boxes. So let's try making our own boxes in example 6. Count how many terms you have. I have 2 terms here and 1, 2, 3 terms here. Now when making your box, to save space, I generally will make count whichever expression has the most terms in it. That's how many columns I'll make. So I'll draw a line, and I need to make 1, 2, 3 boxes across for my 2a, 3b, +3b, and -5. Had the first expression had more terms in it than the other one, I would have wrote that one on the top. Now, my first expression has only 2 terms in it, so I'm going to make 2 rows. this. So my first term is 3a and 4b. You could have done it the other way, and that's fine. It just would have been a tall rectangle. And sometimes when you're trying to save space, you might run into the problem below it. So that's the only reason why I recommend writing the bigger polynomial first across the top, is just to save space. But you will get the same answer the other way. All right, we're ready for our multiplication. So I need to multiply the negative 3a times the 2a, and I'll put it right there in that box. It's negative 6a squared. Then you'll multiply again. You just go across that. Negative 3a times each term in the expression above. So negative 3a, right, so we're ready to multiply negative 3a times 3b would be negative 9b squared. Don't forget that 2 there. Oh, I'm sorry. I take that back. We have an a times a b. A, b. So it's negative 9. Erase that for you. Negative 9ab. Then you'll multiply the negative 3a times the negative 5. It'll be positive 15a. I do recommend always writing in the signs when you multiply, because later on when we combine like terms, it just makes it easier to see if you have same signs or opposite signs. Now we're going to look at the second row. 4b times the 2a equals 8ab. 4b times 3b is 12b squared. And finally, 4b times negative 5 is negative 20b. Combining like terms when you have a trinomial, like what we have here, is the same as the binomial. It's the diagonals that will always combine. So your diagonal boxes will always have like terms. If they don't, then you need to double check something. And I think I do need to double check something. Because I see A, B, A, B, those are like terms. But what's the matter here with I've got a B squared and an A. So I'm going to double check my work. They should be like terms, and try to figure out what I did wrong. Just a minute. Okay, I did some investigation, trying to look, because I was checking on my multiplication. It is correct. But what's different about this problem and other 2-term times 3 terms or a binomial times trinomial is you notice that we have 2 variables here, a and b, so the diagonals may not always be like terms when you have more than one variable. So I'm going to take back one of my circles here. And yes, the 8ab and the negative 9ab are like terms. The 12b squared and the 15a are not, and the negative 20 doesn't have any other like terms with it. So our final answer then is negative 6a squared. We do combine the next 2 terms there. The 8 and negative 9 is negative 1ab. Now we have the next 2 terms. You do look at the diagonals to decide who comes first, because they should be in order from there. And it looks like our b squared has the highest degree, so we should write that one first. So plus 12b squared. And then finally negative 20b, because that is the lowest degree. If you're looking at that and wondering, hey, what happened to the 15a? Yeah, I forgot to write it. So let's try that again. One more time. Let me erase it and I'll rewrite the answer. So the answer is negative 6a squared minus 1ab Okay, So here we have the problem where we have two variables, a and b, and we're trying to figure out what order to write our terms in. When you have two variables, the first variable, which is our a, as we write each term, we want our exponents to be written in descending order. So if our highest exponent was a, we would want a to the second, then a, and then no a. Our b variable, once we've completely finished out our a terms, we would go in ascending order, or starting with the lowest exponent and reaching the end to the highest exponent. So we're going to hold off on that 12b squared because that's a second variable. We want that b squared to be on the end of our answer. So next, as we're looking on here, I have a plus 15a actually I need to back that up a little bit. So as we're going in ascending order, it's a squared, a to the first, a, like no a's, and then our b order we would want to go in no b's, b to the first, b to the second. So that's what I mean by ascending and descending order. So if I look on here, I have, this is my a to the first, and this is my a. But notice that this has no b to it, so that would be like b to the 0. So we would want to rearrange those two. I'm going to erase that and rewrite it. Okay, so what did I just say? We want negative 6a, and then the plus 15a, because that would be like b to the 0. Then we would want our negative 1ab, so that would be like b to the first. And then our negative 20b, because that would be like b to, or a to the 0. So here we have our descending a's. A to the second, a to the first with b to the 0 power, then a to the first with b to the first power. Minus 20b, and what am I forgetting here? I know we're not done yet. Oh, the 12b squared. So plus 12b squared. Sorry, I ran off the room of my screen. But that is a b squared there. Alright, so it does get tricky when we have two variables. Please feel free to ask for help if you need to rearrange. No, most questions, especially like the ECA, they will not count you wrong if you do not have your answer completely in standard form unless the directions specifically state put your final answer in standard form. Alright, to summarize what you just learned, these are methods for multiplication. We have three methods of multiplication. You have the binomial method. I can never spell. B-I-O-N-O-M-I-A-L. Sorry, binomial method. Or I'm going to call it old school method because that's really a misnomer. You can use it for trinomials or anything you want. So I'm just going to call it the old school method. The second method was the FOIL method. FOIL, though, has limitations. It can only be used for binomial times binomial. And finally, I showed you the box method, which, by the way, if you're looking online, it may also be called the grid method. Grid or box is the same thing. You also had a review on ordering polynomials or the standard form. So our rule for your final answer for standard form is that you want your variables to be in descending order. So variables written in descending. For example, 3, 2, 1, that's descending order. If there's two variables, So I'll just put like if A and B. So two variables. I'll write two variables for you. Sorry, I was trying to take a shortcut. You have two variables. Your first variable, which would be like the first alphabetically. First variable you still want in descending order. But the second should be in ascending order. Like 1, 2, 3. Alright, that's the end of this lesson. Go ahead and look to see what your next activity, it might be a guided practice or an independent practice for the next lesson.